Welcome back, everyone. As you can see, we are continuing with three-dimensional shapes today. The last couple of lessons, we've talked about how to find the volume of a three-dimensional shape. Again, the volume is the space inside of a shape. It is not the surface area of each panel added together like we were talking about previously. Today, we're going to be moving on and talking about some things that are a little bit more complex, because I know that most of this stuff is too easy for most of you, and you want more of a challenge, so way to go. As you can see by the title today, it's 8.5, Shapes with Cutouts. So we're going to be talking about some more difficult shapes and shapes that have cutouts or hollow spots that go through the shape. As you can see from the diagram that I have on here, which is this one here, we have a box, and then there is basically a box cut out of it. So it's a box missing a section, and you've seen this before, like when you buy a roll of Lifesavers, you get a roll of candy, but then there's no center candy, there's a hole drilled through it. So you're getting ripped off, and there's actually less candy in the roll of Lifesavers than if it was just solid. So yeah, they're fooling you. Anyway, that's the type of situation that we're going to be talking about. There's a couple of important things when you're dealing with cutouts in a shape. And as you can see here, number one, if you've got a cutout in the shape, you've got less volume. So the volume is decreased because there's part of the container is missing. It's hollow. It's not there any longer. If you think about the like a can of pop, the bottom has a concave area where there's no pop in there. And the bigger that concave area is, the less volume your pop can has. The second thing here that's important is that when you have a cutout in a shape, you actually increase the surface area because you have additional surfaces in there. There's a wall in there, and that kind of like a cave, and those cave walls are additional surfaces to the shape. So you're going to have more surfaces and a bigger surface area, but on the flip side, you're going to have less volume, less space inside the shape. Typically, when we were finding the surface area of a box, there were 6 sides, 6 panels, a front, back, side, and a top and bottom. And we would add those 6 surface areas together to find the total surface area. On a shape like this one with a cutout, you're going to actually be adding 4 additional panels in there, which I will outline. One of them is the wall on the right-hand side. So you're going to have to find the area of that and add it to your original 6 outside panels. Obviously there's the blue one here that matches it on the other side. That would be the wall of the cave on each side. And then in red, I will put, there's a bottom to the cave, kind of the floor of the cave, which is an additional surface. And obviously there's the ceiling to the cave as well. So that is another additional surfaces. So that's 10 surfaces in total for this shape if it's got a cutout. There's the original 6 on the outside, plus the 4 that make up the cutout, the side, and top and bottom. One additional thing you'll have to worry about is that this front piece is missing, so you'll actually have to subtract this missing piece from your total of the front and back. So it does add a couple of more dimensions to one of these questions with surface area. I know what you're saying. Stop talking, nukes. Let's try a question. So here we go. Here is a goofy looking box, and it's got a cutout all the way through it. Let's first work on the volume of this and find out what the volume is for this shape. As I told you before, if I can just find the area of this front and then times it by the depth, which in this case is 30, it says, then I will be able to find the volume of this shape. Now, I'm going to circle this part because we're going to have to subtract it from the front. So the front is 25 by 10, it says on the back. So 25 times 10 is 250. If this box had no cutouts, I would take 250 and times it by 30 and get 7,500. But it's got a cutout. So I'm going to find the area of this little green rectangle, which is 2 by 4. Hey, 2 by 4. 2 times 4 is 8. So it's 8 centimeters. So the whole front is going to be 250 minus the 8 that's cut out. So 250 minus 8, you can do that in your head. That's 242. I'm going to write that back here. 242 is the entire front, which again is the big box minus the cutout. So 242, if I times that by 30, again, that's the depth of the shape. Use your calculator, or do it in your head if you can. It's 7260. And there we have the volume as 7260 cc's, or cubic centimeters. Again, find the area of the front and times it by 30. Now, if we want to find the surface area, well, we've got a lot of work to do. Most of us know how to find the surface area of the box, the outside panel, so let's quickly do that. That's 30 by 25, so 325, that's 750 centimeters squared. The bottom of the box, I'm going to write it over here, is also 750. And then the side wall over here, which is the red one, that would be 10 by 30, that'd be 300. And this side would be 300. So where can I write that? Let's write that over here. I've got 750, 750, 300, 300. And then what do we need next? The front. Okay, that's going to be a little bit more difficult. That is 25 across and 10 high. So that's 250. But I have to subtract this piece that's missing, which it says is, hey, it's 2 by 4, which is 8. So we've already figured that out before. That's 242 on the front and back. So I'm going to write 242 in there instead. Now I'm going to have to add the other 4 surfaces that make up the tunnel, which makes up that box that's cut out. So I'm going to start by this with this one here. This one is 2 centimeters by a depth of 30, because that's how deep this shape goes. So 2 times 30 is 60, and the one on the far side is also 60. So those would be the walls of the cave. I'm going to have to add those as well. And then the bottom and top of the cave, again, those should be identical. They will be identical. So that is a distance of 4, and times that by 30. Again, you can do that in your head, because 4 times 3 is 12, and add the 0 is 120 and 120. So I'm going to have to add all of those up to get my total surface area, which I will put down as surface area. So that's 750, 750, that's 1,500. Plus 600, that's 2,100 so far. Plus 242 and 242, that's 2,584, which is all the outside of the box, plus 60, 60, 120, and 120. So let's do that. And I get a grand total surface area when I add all these things together, that and that, of 2944 centimeters squared. Again, it's squared because I've laid it out flat and we've made it two-dimensional and found the area of each flat panel. So as you can see, there's a fair amount of more work when we're finding area and volume of cutouts. I know what you're saying. Let's try another one. So here we go. Yikes, this is ugly. Let's try the volume first. Again, I like to find the area of this front, subtract this cutout, and then we'll times it by 50 to find out what the total volume is. Again, volume is easier. So this is 12 by 25. 12 by 25 is 300. But we're missing this little tiny section right here, which is 4 times 7 divided by 2. Don't forget to cut it in half. So 4 times 7 is 28, and half of that is 14. So to find out the total area of the front panel, it's 300 minus 14. So 300 take away 14, well, that's 286. So 286. I usually write that on the back wall, and that helps me remember it. And I usually put up the totals on the front wall just because I'm crazy. So I don't really need that anymore. That's old information. All I need is 286. If I take 286 and times it by 50, I'll have my volume instantly. So let's do that. 286 times 50. Use your calculator. 1430 with another 0. So we got 14,300 cubic centimeters, or cc's, centimeters to the power of 3. If I want to find the surface area, oh, I already had volume up there. So let's put that down there. That's 14,300 cube. And surface area. Well, again, that's going to be quite a few steps, so let's give it a go. Got to find each panel now. Luckily, we've already got a head start. We've got the front and back panel as 286. So I'm going to write that down. I got 2 of those. Don't need that anymore. So I might as well write that in there, 286. I have a bottom panel, which is 12 by 50. 12 times 50 is 300. Write that in. Top is going to be 300. So I'll add those. And then we got the big side panel, which is 25 by 50. Again, if you're not sure, that would be this panel, or this side times this side. 25 times 50 is 1250. Big panel. Side panel on the other side, so I'll write that down. And I'm going to have to add the other 3 panels. This is one panel, which is the hypotenuse of that little right triangle, which is 8, and times it by 50. So 8 times 50 is 400. So this panel would be 400. I'm going to add that. It's an inside panel. And this panel in here is 7 by 50. And 7 times 50 is 350. I'm going to add that. And finally, this little panel is 4 by 50. It's the vertical wall inside there. 4 times 50. Well, that's 200. So I'm going to add 200. All of these ones here in green are the inside panels of the cutout. They would be the bottom, the side wall, and kind of the roof of that cave that's cut all the way through. Anyway, I'll add all of those up with my calculator. 286 plus 286 plus 300 plus 300 plus 1250 plus 1250 plus 400 plus 350 plus 200, and it looks like we get a grand total of 4622 centimeters squared. All right, so there we have it. That's the gist of today's lesson. We'll stop there, try a couple of questions, try the worksheet, and see how it goes. Good luck.